When I look at it, it may not seem that bad, but if we go a bit closer here, t is approaching -1 from the right. So that has nothing to do with this first part, but over here in the second part, we have two different things. So as t goes to -1 from the right, what happens here with this 1 over t plus 1? Well, it's going to go to 1 over 0. And so it's going to go to either positive infinity or negative infinity. Let's figure out which one it is. We do know that t is approaching -1 from the right, so it is a value that is just to the right of -1, just slightly larger than -1, which means that in our denominator, t plus 1 is going to be approaching 0 as a positive number. The numerator 1 here is already positive, so that term is going to approach positive infinity. Fine. However, when we go to this other region, or this other portion here, ln of t plus 1, this is going to approach ln of 0. And again, as t approaches -1 from the right, 0 is approaching from the right. And this whole thing, we know it's going to go to negative infinity. So what we have happening now on this entire second portion is that we have negative infinity plus infinity. And this is a problem. This is an indeterminate form. Okay, so we have to fix that. Let's forget about everything else now. Let's go off to the side and resolve that indeterminate form, and then we can come back with our conclusion and plug it all in. So now let's do some L'Hopital's. We're going to have to do limit as t approaches -1 from the right, and we're just looking at ln of t plus 1 plus 1 over t plus 1. So it is infinity minus infinity. One thing that we can do with that indeterminate form is that we can bring these two together. Okay, let's put them together with a common denominator, and that common denominator is going to be just t plus 1. Okay, so we leave the limit alone for now. And if I bring it all together, divided by t plus 1, I'm going to have t plus 1 times ln of t plus 1 plus, from here, there's just going to be a single 1. Okay, so that is fine. This is then the limit that we are looking at. And here again, it may not seem so bad. It might seem like we're just about to go and do L'Hopital's rule. But let's take a look. Do we actually have 0 over 0? Do we have infinity over infinity? The denominator does in fact go to 0 as t goes to -1 from the right, so that's fine. This term here is just constant. It's going to still just go to positive 1. But what happens over here? Okay, and this is where things get a little bit weird. As t goes to -1 from the right, we have that this term is going to approach 0, and this term is going to approach ln of 0. And so that is going to go to negative infinity. And we have the product of these two. So what do we have? Well, we don't have the indeterminate form 0 over 0 or infinity over infinity necessarily. What we have is the indeterminate form 0 times infinity, and we need to resolve that. Okay, just in the numerator. So let's take a look. What is the limit as t approaches -1 from the right of t plus 1 times ln of t plus 1? Okay, this is our 0 times infinity, and we know with 0 times infinity we're going to turn it into either 0 over 0 or infinity over infinity by taking one of the two functions, putting them into the denominator. Here, let's take the t plus 1 and put it down into the denominator, which leaves us with ln of t plus 1 divided by t plus 1 to the -1. Okay, And now here, do we have an indeterminate form? Which one do we have? It should be either 0 over 0 or infinity over infinity. And the numerator here, as t approaches minus 1 from the right, it does go still to minus 1 or minus infinity. And here, this one is going to go as well to infinity. So we do have an indeterminate form. We have infinity divided by infinity. So we can use L'Hopital's. We get limit as t goes to minus 1 from the right. We differentiate the numerator. We get 1 over t plus 1 multiplied by 1 from the chain rule. In the denominator, we can do a chain rule. We bring down the minus 1. We decrease the exponent by 1. Plug in the inner function, multiply by the derivative of the inner function. And now all we have to do is simplify this and see what's left over. So let's forget about those minus 1s. Let's just sort of rewrite this, see what we have. T is going to minus 1 from the right. Let's actually just bring this t plus 1 to the minus 2 up. So we end up here with t plus 1 to the positive 2. It's still all negative, but it's going to be divided by t plus 1. And so looking at this whole thing, I could cancel out this t plus 1 in the denominator for one of these in the numerator, and then we see as t goes to minus 1, really we just have a straightforward limit now. We just have minus t plus 1. As t goes to minus 1, this is just going to go to 0. Okay, so we're done that portion, but let's make sure we go back and sort of keep track of what we've actually determined. So here, limit as t goes to minus 1 from the right of this. That limit we just showed is 0. So that's fine. That means that this whole thing right here, that approaches 0. Okay? So now, that means that this limit, as t approaches minus 1 from the right, actually we don't need that. Let's get rid of it. What we have is the first term, which is 0. That's this one right here. Plus 1 from here. That's our numerator. And in the denominator, we have that our denominator is going to 0. So you see we have 0 plus 1 over 0. We don't actually have an indeterminate form at all. Instead, what we have is an infinite limit. This is going to be either going to positive infinity or negative infinity. The numerator is definitely positive. Let's take a look at the denominator. As t goes here to negative 1 from the right, that's going to remain a positive term. And so putting that together with our positive numerator, this whole thing is positive infinity. Now, that means it is dne. And here, if we go back up, looking at our original limit, that means that this whole thing here, this whole second part, goes to positive infinity. That whole second part is dne. So now, hopefully you're still with me, let's go and take this whole integral, the ln of, including the ln of 3 plus 1 over 3, and let's see what we have. So therefore, the integral from minus 1 to 2 x over x plus 1 squared dx is going to be equal to ln of 3 plus 1 over 3. And that second part goes to positive infinity. So we know the whole thing is going to be dne. The whole thing is going to be divergent. So that area between the curve and the x-axis This area over here on the left, okay, that one is going to be infinite. It's going to be divergent. One thing I do notice here, though, now that we're looking again at the picture, is that this infinite area that we're looking at is entirely below the x-axis. So even if it's infinite, it should actually go to minus infinity as a definite integral, not to positive infinity. So let's go back actually to our notes and let's see what happened here. Okay, so this should not be going to positive infinity. It should go to negative infinity, and I have a feeling I just made a copy error. Going back here, this was in fact being subtracted, okay, and so even though it goes here to positive infinity, it should be subtracted. So let's fix that. What we do end up with is here negative infinity, still dne, still divergent.